This class video is regarding geothermal energy. Geothermal energy, sources of geothermal energy, then types of the different wells which are used in geothermal energy, and different methods of harnessing that geothermal energy. Then, then some schematic representations. Finally, how in India, what is the scope, challenges, that much we will see in this video. This is a very small video. Okay, so sources of geothermal energy. Uh, Sources of geothermal energy. Okay, now this is okay. Sources. The geothermal energy it originates from the natural heat of the earth, which is primarily derived from the radioactive decay of minerals and the original heat from the planet's formation. That means the the center part of the earth, where we can see there is a temperature is very high, so there the water content, or if we supply water to that particular area, it becomes steam. And the steam, if we have a provision to come out, it will come out. That means if we have the pipes connected to that area, to that level, then the hot water or the steam, it will come up, and we can use that high energy steam from production well to rotate the turbines, get electricity, and whatever steam or water produced there, that can be pumped back to the injection well. Well means, I am calling it as pipe, but it will be a bigger pipe, therefore we can call it as a well only. Okay, so that is about the general introduction to geothermal energy system. I have already seen this one in first module. Okay, so now little bit details of that. Little bit details, not much. So the main sources of geothermal energy, it includes the geothermal reservoirs, the magma bodies, hot dry rocks. Geothermal reservoirs, they are the natural underground formations which contain the hot water stream. Okay, so they are found in areas with high volcanic activities, or tectonic plate boundaries, means where the movement of the earth surface cracking and movement which is happening, we call it as tectonic, different connecting areas called tectonic plate boundaries. Not exactly, I'm not getting the exact word of that. Anyhow, I've understood. So volcanic activities where the tectonic movement, where it is that boundaries are there, and even the hot spots where we get hot gas coming out from the earth surface. Such areas, we can think about having a geothermal reservoirs, or it may be magma bodies. It is in the regions of volcanic activity. The magma which is close to Earth's surface can heat the nearby rocks and water. Such places also, that water, hot water, it can be, if you have a digged well there, the water will come out as a steam. Hot water come out as steam, and it can be used to run the turbine. And whatever the cooled water, it can be pumped back to the same area. Again, it will heat up, you get the steam. So it will be a cyclic process there. Then it may be hot dry rocks. So these are the areas where the rock temperature are very high, but there is little or no water. So what we can do, we can artificially fracture, uh, uh, make it as a tank type of structure, and we can allow water to be sent to there, so that it will heat enough. So the hot dry rocks are drilled and made fractured and made passage for the water, so that when water passes through that area of that rock, it will convert into steam, and that steam can be used. Okay, so that is also another option. Now the types of different geothermal wells. I'm sorry. Okay, types of geothermal wells. Geothermal wells are they are the drilled to access the Earth's heat. Based on the usage, there are production wells, there are injection wells, there are observation wells. Okay, so first image I'll take. Okay, so these are production wells. These two are representing the production well, and the blue one indicate the injection well. We can have one more well dig to see, only to check what is the temperature inside the earth, what is the movement of the water or steam there, to observe the things what is happening inside. We can have one more well, that is called observation well. Okay, so now we understood production wells are drilled to get the hot water or steam to the surface, whereas injection wells are to re-inject the cold water back into the reservoir. Observation wells are used to monitor the pressure, temperature, or any other chemical properties, chemical reactions happening in the reservoir. Based on the depth that we are drilling, there are three main types: shallow wells, intermediate depth wells, deep wells. Okay, so word itself it is clear. Shallow wells means not digged too much. So these wells tap into the earth heat at depths ranging from few hundred feet to a few thousand feet, and they are commonly used for heating and cooling purpose in residential and commercial buildings. Intermediate depth wells, okay, so this one it can be used even in the cold areas, where to heat the building, inside the building, to decrease the temperature of uh, increase the temperature of the room, or inside the big buildings. They can have this type of setup, where the hot air or hot water convert into steam, and heat is generated, and the cold one it is passed back to the well. That possibility it is there, and they are using it. Therefore, that's for this example is given. Intermediate depth wells, these wells they reach a depth of around 3000 to 10,000 feet, accessing higher temperatures. They are primarily used for power generation in the geothermal power plants. Then comes the deep wells. Deep wells, they can extend to depths of several miles, accessing extremely high temperature. They are typically used in enhanced geothermal system or geothermal heat pumps for large scale energy production. Big shots, they go for that. Now, methods of harnessing geothermal energy, different methods or different ways of getting that energy. First, I will show you the images. One setup in which uh, heat is production well is there, turbine is there, injection well directly, and we are getting electricity. Second one, in which production well is there, there it is connected to some other system from the directly the production well steam it is not used, something else is used to rotate the turbine, and finally water is pumped back to injection well. Third one, that production well is there and it is used, there is a heat exchange takes place. After heat exchange, that heat is used for turbine rotation, and injection well it comes back. We are getting electricity, we hope. This type of one in which the big rocks inside the earth, hot dry rocks, which made holes to that, and water is pumped there, and hot water is taken out to get electricity. Another one, this is heat pump systems. Uh, Deep wells are used, and again the water is taken, the heat is taken. Reverse case it is. Yeah, blue represents hot here, red represents cold. For evaporator, evaporated. Okay, we'll see. In your explanation is there, we'll read it. Forgot this one. We'll see. Okay, one by one we'll see. These are the several methods to harness geothermal energy, depending upon the temperature and the characteristics of the geothermal resources. Dry steam power plants directly use geothermal steam to run turn turbines connected to generator. Very ideal for the geothermal fields which produce dry steam. Okay, in USA it is there on this particular place, California. Flash steam power plant. So the process in a flash steam power plant, the hot water from the geothermal well is passed through a separator where the drops in pressure causes the water to instantly convert into steam. That is flash steam. Okay. The steam is then directed to turbine to generate electricity. Okay. Hot water is taken and it is compressed, or it is drop in pressure. The pressure is decreased so that when pressure decreases, the hot water suddenly convert into steam. That is called as flash steam. Suddenly produced steam in a flash by decreasing the pressure. We call it as flash steam, and that flash steam is used to take the turbines. Suitability suitable for geothermal resources with temperature above 180 degrees Celsius. Italy it is there, that is Laterallo. Binary cycle power plants. It uses a secondary fluid, a binary fluid, not the hot water or steam coming from the earth crust as such. Some other liquid, high boiling, low boiling temperature liquid like ammonia and all. With less heat only, it will be converted into gaseous form or gaseous form, and that gas pressure can be used to rotate the turbines. Okay, it's a secondary fluid which vaporizes and drives the turbines. That is the binary cycle power plants. Even the low temperature resources, if the temperature of the water or steam coming from the geothermal well, production well is 90 to 180 degrees Celsius also, it can be, this particular system can be used. That is the Chena hot springs of Alaska, USA. Then comes the enhanced geothermal system. Artificial fracture hot dry rocks to create a reservoir. Water is injected and the heat, and it is heated by the rocks and then extracted. That is this particular one, fractured zone created. Useful in areas without natural geothermal reservoirs. Example in France, salt source forest. Okay, I think you heard how I pronounced it. Now it's up to you to take it up. Now geothermal heat pump systems. Geothermal heat pump system, they transfer heat between the ground and a building using a ground heat exchange and a heat pump, effectively utilizing the stable temperature beneath the earth's surface for heating and cooling. Geothermal heat pump system, they transfer heat between the ground and a building using a ground heat exchanger and a heat pump, effectively utilizing the stable temperature beneath the earth's surface for heating and cooling. Okay. So these systems are suitable for various climatic or locations, particularly where there is a sufficient ground space for installing the ground heat exchangers, and they are especially effective in regions with a significant temperature variation between seasons. That is in United States. Means so you can imagine that this is a building, and this is the underground where there is a stable temperature. Okay, and the pipe connections are made circulating such a way that if the room is having it is getting cooled down, very cold condition if it is there, then from the ground level underground where the temperature is not varying constant temperature, that temperature, high temperature, it is used to cool. When the earth surface or the building it is more hotter, to cool it down, then it is reversed. That time also the earth the underground, the temperature is normal, the same temperature only, normal temperature only. Therefore it is used as a reverse case. Both case, when there is a too much fluctuation in temperature, very hot conditions, also the very cold conditions, also the such buildings, such areas, this type of setup can be used. That is also energy form, therefore it is used. So, so example, Ball State University in Indiana, they are using, of United States, they are using this type of a setup. Now, the scope in India. India had significant potential for geothermal energy, though it remains largely untapped. It is not yet utilized. Geothermal provinces. India has several promising geothermal provinces, including the Himalayas, Western Ghats. The Western Ghats is ours, here only nearby. Okay, and Andaman and Nicobar Islands. We have geothermal provinces. Hot springs are the numerous hot springs are scattered across the country, indicating the geothermal activity. One is there near Puttur. Find and give me where it is, or tell me where it is. Pilot projects. The Puga Valley in Ladakh and the Manikaran area in Himachal Pradesh are notable for pilot geothermal projects. The challenges: high initial investment, lack of technical expertise, limited exploration data. Okay, you students learn some of this method. You become expert and get it installed in our India. Opportunities, yeah, opportunities, renewable energy policies, the government incentives, and the technological advancements, it can drive the development. Opportunities are there. Challenges are also there because we don't have high initial investment required. It is possible if we have a very good experts who can tap energy conversion, conservation. That is separate topic, separate video.